Welcome to week one of Introduction to Python, and in this week we're just going to be covering some general introduction to Python syntax, the Spyder environment that we're going to be using as our integrated development environment, and just go over some basic rules when it comes to Python. Now, last week we covered installing packages using Anaconda, and we installed Anaconda, which is our distribution that we're going to be using here. Now, Anaconda, as I said before, is pretty much the most popular Python management piece of software, and again, it's just free software, which is very nice. But let's go ahead and let's open up Anaconda here. So I'm going to go over, for me, it's in my applications folder, and I'm going to open up Anaconda Navigator. And so once again, this just houses everything. This is a one-stop shop for what you need for Python, and you can use different IDEs from this point of view. There's a lot that you can do. So notice that when we load this up, this navigator here, we are under base right now. This is our base environment. And when I say environment, remember, this is just a sandbox, a sequestered collection of packages / modules that play nicely with each other. Remember that a lot of packages have different dependencies, and different versions, newer or older, of certain packages have different dependencies. So for the same package, if you're using CartoPy and you install a new environment with a new version of CartoPy, it might use a different NumPy version dependency. It might use 2.2.2 instead of 2.2.1. So the rule of thumb is to create a new environment that does not play nicely. Another way to think about it is just actual environments in nature. Whatever exists in a jungle does not exist in an Arctic tundra. So we keep our environments separate. And in this case, yesterday we created this environment called GEOG 3.8. So I'm going to open up that environment and notice that it has to load up things that we have installed under this environment. So we'll give it a couple seconds here, wait for it to load, and there we go. Remember that in the previous video, I installed Spyder at the very end. So for me, I just have a launch button. You might have an install button, so go ahead and install that if you don't have it installed already. But I'm going to go ahead and I'm going to launch Spyder, which is a development environment, not to be confused with our Python environment. So this integrated development environment is just a fancy name for an application that makes coding in Python easy, or coding in general easy. So it's just our application that makes it easy to code. So the first thing that we notice here is some pre-written text over here. You might not have this exactly. I'm not sure why this popped up this way, but at any rate, this is our script portion right here. So this is our canvas. This is where we do all of our coding, our editing, this is where we write everything that we need for the script. So this is the file that we save. We can open again, edit, and so on and so forth. Whenever we want to execute this code, we execute it in the console. Now, there are ways where you can send all of this code to the console. For example, this play button will play this entire file right here. And notice in this script that it loaded up, I don't know if this is a pre-written script that I wrote or what, but notice that there's 3 X's right here. So those are bugs in the code, and it's telling me that X is not defined, meaning that we need X to be defined somewhere. It has to be a variable that exists, because otherwise Python doesn't know what the heck that is. So this is our script. This is where we type everything out, code it up. This is our console. This is where we run everything. This is our variable explorer. So this tells us what actually does exist. So if we were to actually come down here to the console and explicitly write x equals 10 and hit enter, x will now pop up over in a variable, and it would have been better practice to come over here and say x equals 10 in the script, so that way it's saved in the future. Whatever we write down here in the console does not get saved. It only gets saved if we write it over here in the script. So just for fun, let's go ahead and run this again and see. Well, it ran that time. My x's are gone over here because, my red x's I should say, because the variable x is defined. And now I have this plot. And does it make sense? No, but this is exactly what we wanted. This is the plot that just gives us a nice window. And we'll get into the specifics of how to create this and so on and so forth, but I just wanted to run through. This is also our plots window, so we can roll through these tabs. We have a Files tab, we have Plots, Help, and Variable Explorer. So this is what Spyder is, and again, if we type code over here, we execute it or run it in the console. The other way you can execute code is you can just highlight what you want, and this button right here is Run Selection. So it will just run what I have selected right there, and this is my preferred way to do it, because I like running things piece by piece. The other thing is that if you're just right here, just your cursor's on that line, you can select that and it will just run that line and then move forward. So this is also F9 if you have a keyboard shortcut available. So you can just hit F9 and it will run this white button right here. But so when I ran that, I now have it ran X down here, so now I can print X. X is 10, which is the same as explicitly printing X right there. So this is Spyder. This is what we're going to be using as our application. But let's come back here. Let's come to the course website and let's open up the week 1 tutorial, which is just an introduction to Python. So I kind of covered a lot of this already, and just to prove to you how amazing Python is, this is a popularity of programming language, and number 1, Python. It makes up over 30% of the share, which is pretty remarkable. And there's R at 7 for those of you who took that portion of the course with me. So again, we're using Python 3, and I kind of talked about that yesterday. Just be careful whenever you're searching things, searching for help, for coding help online, such as at places like Stack Overflow, which is an amazing place where the most amazing people will help you with your coding problems for free, just because they're amazing people. And you will find answers in Python 2 and Python 3. Now, the syntax is a little bit different, so you just have to be careful. I mean, it's basically the same thing, but there's just if there's a Python 3 answer, stick with that. So here we go, terminology. I'm not going to run through this individually, but these are just some definitions that are really important to know, and some terms that I'm going to be using here in the future. And one of those terms is variables. So in math and physics, variables are often part of equations or formulas. However, in programming languages, they are much more flexible and can be assigned a value. And they can be combinations of numbers and letters. It's case sensitive. It can be strings. It can be just about whatever you want. And when we are assigning a variable, we assign it using the equals sign, which is the assignment operator. So it's just good practice to refer to this as the assignment operator as opposed to equals, but it's okay if you refer to it as equals. But yeah, every variable, this is the only variable assignment operator. So if we come down here, this is our code right here that we want to mess around with. So let's go ahead and copy this back over. And real quick, I'm just going to switch up my order of my windows. Click back over here to Spyder. I'm going to remove all this. I don't know what the heck that is. Copy this over, highlight it all, press the white button, and now we have var 1 through 5, or excuse me, 6, right here. And so var 1 is just 1. And I can run a type function on var 1, and it tells me that it's recognized as an integer. So The nice thing about Spyder and about using this IDE is that you can use tab autocomplete. So if I write var or VA and hit tab, these are my different options. Okay, this just says Python is like, okay, or Spyder I should say, is like, okay, here's what you could mean when you type that out. It might mean var1, var2, var3, whatever, select what you want, double click it, hit enter, and there it is. The other thing that tab is really useful for is if we type the beginning of a function, such as print, and hit tab, double click, now I can use this function, and then once I initiate that function using that first parenthesis, I can run a little help box comes up, tells me what's going on here, it prints values to a stream, and so I can print var4, close those parentheses, and it'll just print that out like so. How do we know print is a function? It's a function because of these parentheses right here. There's also a function, another way to tell is just because Spyder does something really nice for us. It just recolors it for us. Notice that the variables are in white, the functions are in orange right here. So that's a nice feature of Spyder, just kind of helps us get used to it, familiarize everything, and just play around and understand Python. So the other thing that we can do is we can convert a value to an integer. So if we have a value x right here, so let's go ahead and run this one line. And then I'm going to run a type on x here. X is a float, otherwise known as a floating point number, meaning that it has trailing numbers after a decimal place. I can use the int command like so. So y equals int of x. Now if I print y, it's 5. And if I run a type on y, it's now an integer. So that's what that did right there. And then I can use the print function to print multiple things separated out by a comma. Hit the white button and boom, 5 is a class integer, 5.333 is a class floating point number. We can also assign variables and then use them in an equation, just like we would in math or physics. So if we declare temp C to be equal to 10, and then we say the Fahrenheit version of this Celsius temperature is going to be the Celsius temperature times 9 over 5 plus 32. So just like we would with a math equation, I'm going to go ahead and run that, and then I'll print out temp F, and it's 50 degrees. So 10 degrees Celsius in Fahrenheit is 50 degrees. So these are kind of the different operators that you can use for mathematical equations, which is just really helpful, really nice. So just like you would put it in a calculator, you would put it in here with Python. So now we have an in-class exercise, and this is some basic geometry, but we'll see how this goes. I'm going to copy those over, put that on a new line. Make sure there's no red X's over here. And I'm going to go ahead and run these two. Now what I'm going to do is I'm going to say, okay, C is equal to height squared plus width squared. Run that. C is equal to 65, and now I just need to take the square root of C in order to figure that out. So we come back here, and the other way we can do that is we can just take the exponent to 1/2, so we can say C to the 1/2. So C is equal to 8.06225. So I'm no geometry expert, but I think that that's right. I think that that's how it would work. So the other way we can just do this is we can just say, we can put these in parentheses and then just take that to the 1/2, and then our hypotenuse is the same thing, 8.06. So correct me if I'm wrong. I'm pretty sure that that's right. It's been a while since we've done geometry. And we just come back here, and sure enough, a squared equals b squared equals c squared. So that's good. I didn't just embarrass myself by calculating that incorrectly. That should be right. So as we mentioned before, we have these variables over here. We have different data types that are associated with them. So we have these different types over here. We have integer, floating point, complex numbers, strings, also known as character strings, Boolean operator, which is just a binary operator, true or false, also known as logical operators. And then we have special values, such as none, to indicate the absence of a value. So I can copy all this code. I already have this copied over, so I'm just going to copy over this print part. And then let's go ahead and let's white button that. And we have value 1 is of type integer, value 2 is of class float, and so on and so forth. Containers are data types for holding many variables. So we have all these variables up here, but we can also use different things such as containers to contain all of them, such as lists. So a list is just a one-dimensional ordered container, and the length can change, meaning it's mutable. So let's go ahead and let's copy over this first line. So weather equals rain, snow, and hail. Select that, click the white button, and now I can come over here to the console and I can print out weather as rain, snow, and hail. Then I can print it out and I can print out the length. And notice that for this print statement, I added in some extra metadata here, such as length, and I did that by putting everything in quotation marks. Anything put in a quotation mark is a character string. So what I said was that length is equal to this length function, or len function, of weather, and it's 3 long. Makes sense, rain, snow, hail. The other thing you can do is it doesn't all have to be the same. We can also have a mixed type list, such as rain, 4.5, 99, and none. So I come down here, get ready, go ahead and run that, and same thing. Now, we can also add or remove things from a list. So let's say we take our initial weather list, rain, snow, hail, and then we want to add drizzle to it. We can add it using this append function. So weather, let's go ahead and let's do a type on weather. Weather is a list. Lists are mutable, meaning that you can add or remove things from them, elements from them. The way that we're going to add is we're going to do .append. And if you're ever confused about this, come down here, weather dot, and then I can hit tab. Weather dot, and then these are all the different functions that we can use on this weather list right here. I want to append, and I want to append drizzle to it. I'm going to go ahead and run that, and now weather is rain, snow, hail, and drizzle. I can also use this insert function, and I can give it a place. I can say, okay, I want to insert grapple. It's a type of hail. A little bit different, but you can think of it as basically hail, special type of hail. And we want to insert it at the first position. Now, Python is 0 indexed, meaning that the first index of weather is rain, but the first index is 0. So it's 0, 1, 2. So if I type weather again, drizzle is going to be the third. 0, 1, 2, 3. Weather, 3 is drizzle. Now I can insert this, I can insert grapple as the first the first element. So where's that going to go? 0, 1. So it's going to take the place of snow. But we're inserting it, we're not removing snow. So if I come down here and run it, we have rain, grapple, snow, hail. Let's say we just want to remove rain. Let's redefine our weather list as rain, snow, hail. We can delete the 0th, aka the first element, from the list. Come up here, run this. So now it's just snow and hail. And we did that using this delete. And delete or del is a special function. It's a special function because it's a global function. And that's why for this particular special case, there is no parentheses following it. There's only a handful of things that this exists for. Delete or del is one of those. We can also use a .pop function where we remove the last item from the list and store it in a new list. So now we have observation as hail, which removes the last item, puts it in a new list called observation, and then we have weather, which is just rain and snow because hail got pushed over observation. So now what we want to do, now you kind of have an idea of how to combine things. Let's, given the list of weather above, let's extract snow from the list and print a statement that says within the last 4 hours there have been 5 inches of snow. So all we're going to do is we're going to copy this over and store it as text. And we want to extract snow from this because who knows, this could be changing. So text, run that. Text is just within the last 4 inches, there have been 5 inches of blank. And what we want to do is we want to create the statement that says within the last 4 hours there have been 5 inches of snow. And we know that snow, as our current weather list stores it, is the 0, 1, the first index. So we can put text plus weather 1. So we can index it using these brackets. Add those together, and it adds these two strings together to make one string that says within the last 4 hours there have been 5 inches of snow. So elements of a list can be changed. So just as down here we have weather, and we can say weather 1 equals snow, we can say instead weather 1 equals hail. And now weather equals rain and hail. Again, this is indexing right here. So we have weather 0 is rain, weather 1 is hail. And then if we append something to this, we say weather.append, we want to add something back to this. Let's add drizzle to it. So now weather looks like this, rain, hail, drizzle. And let's say we want to print out 1 through 2. So we want to exclude rain. We can do that using the colon operator. So notice how we had to do 1 through 3. Now let's just go over this real quick. Weather 0 is rain, and real quick, just a quick pro tip, if you press up on your arrow keys, it'll bring up what you just typed above. Weather 1 is hail. So weather 2 is going to be drizzle. So now, if I want to print out just hail and drizzle, I want 1 through up until 3. So even though drizzle is the second element of this list, in order to print it, we want 1, 2, up until 3. So when we use this colon operator here, which means 1 until 3, 1 until 3, it's printing out 1 and 2 all the way up until the third element, which doesn't exist. So we are not printing out the third element even though we have this 3 here. Just hail and drizzle get printed out. So this is a really important thing we have to index here, and just as a reminder, if I print out weather 3, index is out of range. Nothing exists there. So when we use the colon operator, we're taking a slice. We are slicing this index. We're just taking a slice of the index. In other words, we are subsetting the index to just specific elements we want. So that we just talked about down there, that's list slicing. So if we have this long list of weather, and we select elements from index 2 to index 4, let's see, 0, 1, 2, 3, 4. So weather 2 to 4 should print out 0, 1, 2 should print out 2, 3 should print out drizzle, up until 4. So it just should print out hail and drizzle. Let's go ahead and run that. And sure enough, it printed out hail and drizzle. So now I'm not going to run through this one, but as an in-class exercise, given the longer weather list above, slice out a statement and add these character strings together that says NWS says that rain, snow, and sleet are possible tomorrow. So now we leave lists and we get into tuples. And a tuple is basically the same thing as a list, only it cannot change. It's immutable. So we cannot overwrite the 0th index, which is rain, as sleet in this situation because it's a tuple. So tuples are just lists that you can't change. And notice that instead of being stored in regular brackets, they're stored in parentheses. So that's how you identify a tuple versus a list. Now, a really cool thing that we can do with a tuple here is we can identify and store variables like so. So we have this observations tuple as rain, snow, hail. It's a tuple. Now we can extract each element of observations and store them as their own variable in one line. So check this out. Obs1, obs2, obs3 equals observations, which is rain, snow, hail. So it's going to store all of these as one. So we have obs1, obs2, and obs3 right there. And if I actually print this out like so, obs1 is rain, obs2 snow, obs3 is hail. So now we get into character strings, and we kind of talked about this already, but you can add strings together. You can convert a float to a string using the string function right here, or str. You can format strings. And this is getting into a little bit more advanced stuff, but what we can do here is we can use x, so we can plug it in to these curly brackets like so. So the value of x is, and come down here, the value of x is 9.35. So the reason that I plugged that in is because immediately following this string, I did dot format of x and put that inside a print statement. You can also use the modulo operator, which is a special operator that says the value of x is s. And so the first string modulus indicates the format of the variable, and the second after the second parenthesis. So all that means is that we are going to print out, come over here and run. All we're doing is we're printing out the string version of X. So that's a little bit more advanced, don't worry about that, but let's write a string that says GEOG 473.673 is the best class ever. So now given the following. So run through that exercise. And then let's come back here and talk about dictionaries. So dictionary is essentially a list that has a pair with it as well. So it has a key and it has a value. So just like a normal dictionary is, each word has a definition and it's set to that definition. In this case, each key has a value specific to it. Now, dictionaries are created using these curly brackets. So if I come down here, I can run this, and dictionary D is going to look like that. So sight is paired with kdocs, wind speed is paired with 20, wind direction is paired with east. So let's take a look at this. My pairings are paired using the colon operator, and each key and value pairing is separated by a comma. So I can print out the keys So sight, wind speed, and wind direction. I can print out the values. Come over here, press up. And I'm missing a parenthesis. The values is kdocs, 20, and east. And then I can add different things to that. So we can query these definitions. So D has a sight key in it, which has a value of kdocs. So remember earlier we said D, we would index something or we would subset something using the indexing operator. 0 is not a key in a dictionary. These do not have numerical indexes, just like lists do. They're a little bit different in that we need to reference our word to find the definition. We need to query or call upon our key to get our value. So that's why we need to subset using D of sight, which is kdocs. Entries can be added or removed from dictionaries just the same with lists, and they're removed the same way. Delete. We can add things in. We can redefine, just like this. So, and really getting towards the end here, the last thing that I really want to cover, last couple things, is the for loop. We're not going to really get into these too much, but all you need to know is that a for loop executes a block of code for all items in an iterable object. So this is a for loop syntax: for a variable to iterate, in sequence, colon, do this code. Every for loop is tabbed over. So it's a little weird, but this is exactly how the syntax goes for for loops here. So for is one of those special functions, or in this case, commands in Python. Notice how it's a different color from everything else, just like del for delete was up here. So we can say for x in weather, and then I hit colon to end the start of my for loop. Now I come to hit enter, and notice that I'm automatically tabbed over because that is exactly how we place what is inside the for loop. Print x. So x is this variable it's going to be interchanging for everything, every object within weather. Come over here, run it, and in my weather list, we have rain, snow, hail, drizzle, graupel, sleet. So this is the way a for loop works. The other way we can do it is we can do something like this. For x in 1 to the length of weather, or in this case we should make it 0, because remember we're 0 index. Now we can print x. Run that. Oh, yes, an invalid syntax. I need to place this in some parentheses so it doesn't think that it's ending. And actually, I can't use this. I'm stuck in R mode. So let me go back here and let me say that I want a range from 0 to the length of weather. Sorry about that, stuck in R mindset. And so now we have for x in range of 0 to the length of weather. So I'm just going to copy this down here real quick. The length of weather is 6. So we go 0 up until 6, which is 0, 1, 2, 3, 4, 5. So that's basically all you really need to know for a for loop. I have some different examples in here on how you would use those. And try and go ahead and debug this code to make it actually work and make sense. So there's bugs in this code. It is designed to not run, and you need to add some things or change some things around to make it run. Now, real quick here, let's just get into, I'm not going to cover functions. I just wanted to be here for you so that you understand what functions are, how they work, because you can write your own functions, right? But yesterday what we did, or in the previous setup video, what we did was we installed packages, also known as modules, also known as libraries. A little confusing, there's a lot of different words here, but all that a library or a module or a package is functions that have been pre-written for you. And if you want to use some of those functions, we need to open that library up. The way Python is organized, and the reason that it's so light and light on your computer, and one of the reasons why it can run so fast, is because you're not loading in everything you possibly have on your computer. For example, when you have Microsoft Excel, when you load Microsoft Excel and open it up, you are opening up every single tool available. In other words, you're opening up every single library or package or module that can be used with Microsoft Excel all at one time. So when you open it up, everything is usable. Python is not that way. Why? Because it's designed to be light. We don't want to open everything up because it would tax our computer, and we only want to use specific functions most of the time. So we need to open that up and call that ourselves. The way that we do that is using the import function right here. So if I come back over here, I can import math. And I have a little warning sign right here, but it doesn't matter. So let's go ahead and run that. So now we imported math. So now I can use things in math such as square root. Math.square root. So when I open up math, Python opens up the math library and stores it as math. So now we have math.function. So we can use math.hit tab. These are all of the different functions available from the math library or package. So that is how they work. That's where we need to load them in. And typically you want to load them in up at the top all at once. So we can load in import metpy, import pandas, import cardopy. And the reason that these little warning signs are popping up is because these are unused. meaning that we're loading up these packages, but they're not being used. Why is it doing that? Because we want to keep everything as light as possible. We only want to import what we need to run the script. So if we're using functions from these packages, MetPy, Pandas, or CartoPy, then we should load these packages in. However, we're not using those packages. We're not using any functions, so we don't need them. But typically, you would want to put them up here, and I'll just put a little note. And I'm noting this using the pound sign, which indicates that this is a comment, and I don't want to run this line at all. This is just a simple note. And you want to comment your code as much as possible. Typically, you want to load packages at the top of a script. And then put a little note. This script is week 1 intro to Python. So that kind of concludes everything running through this specific module. Again, run through those class exercises, debug this code, and try and figure that out. And then run through functions as well. We're not really going to get into functions too much, but it is important to know that this is available. So every time you are loading in a library, you're loading in functions, and this is how you would go about writing your own function if you actually wanted to create that. So now that I'm done here, all I'm going to do is I'm going to come up here, I'm going to do File, Save As, and I'll just come over here, and I'll just save it as week1.py. Every Python file is going to be saved as a .py extension. Click Save, and now I can come back and use this script whenever I want.